So we're here to present a quick lecture on energy sources and production. My name is Ashley Manning. I am an Energized Colleges Fellow with Climate Corps. I currently work at Chico State. I'm helping write an energy master plan for helping get the school to zero carbon emissions by 2030. And Katelyn, who is a colleague of mine, will take a second to explain what she's been working on.
Yeah. Hi, everyone. I'm Katelyn Peaks. I am a Climate Corps Classic Fellow working at the California State Teacher Retirement System in Sacramento. They're currently building a new headquarters, which is going to be LEED, Well, and Living Building Challenge certified. So a lot of my past 7 months has been working on the red list for the materials pedal for the Living Building Challenge certification.
Awesome. Thanks, Katelyn. So if we go to the next slide, I'm going to start with a video for us on electricity generation and transmission. I was going to try to explain this to everybody and realized that a quick 3-minute video can do a much better job than I can. So if we hit play, it should work.
Here's a question for you. How many people does it take to turn on a light bulb? The answer seems simple. Just walk into a dark room, flip a switch, and instantly you can see, right? Well, the truth is there's a lot more to generating and delivering electrical power than you've probably imagined. Hi, I'm Lee Patrick Sullivan with Energy Now, and this Energy 101 video explains the system used to generate electricity. And it also explains what it really takes to turn on a light bulb. In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuels like coal and oil, but others are unlimited, like solar or wind power. But a lump of coal or a strong breeze alone won't create the power that turns on your light. For every energy source, a chemical or mechanical process is required to turn it into usable electricity. Every day, researchers work to find innovative ways to use our limited resources, process raw materials, harness renewables more efficiently, and find entirely new energy sources. Today, the majority of America's electricity comes from thermal power plants. Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside a generator. It's the generator inside a turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states. Transporting electricity from the power plant to your home is an entirely different process. Current technology cannot cost-effectively store large amounts of electricity, so significant challenges exist when it comes to transferring that electricity across long distances. Just enough electricity has to be generated to meet demand at all times and be transmitted through power lines to reach your light switch. Too much or too little power can crash the transmission system and cause a blackout. That's why a complex mix of logistics, management, and infrastructure is needed to transmit electricity from power generators to consumers. Enter the electricity grid, also known as simply the grid. The North American electricity grid is actually made of 4 large grid systems: the Western grid, the Eastern grid, the Texas grid, and a grid covering the Canadian province of Quebec. These independent regional networks of power plants and transmission lines carry electric energy at high voltage within their area to local utilities. There are very limited links between the four grids, which means electricity generated from a wind turbine in West Texas cannot reach an apartment building in New York City. For electricity to move through one of the four grids, its voltage must first be increased by a device called a transformer. Then the electricity can travel long distances across high voltage transmission lines. These high voltage lines are generally strung between giant metal towers. They stretch for miles from power plants to local substations in each neighborhood. You've probably seen substations along the side of the road and wonder what they do. Well, their job is stepping down electric voltages from levels as high as 765,000 volts closer to the 110 volts you use in your home. The electricity from the power line on your street passes through another transformer, which steps down the voltage once more, and then it travels along the line into your house. From there, the electricity enters your breaker box, and it is then distributed to light sockets and outlets. All you have to do is flip a switch. So, as you can see, from the raw materials to the power lines on your street, there's so much more to the electricity ecosystem than meets the eye.
Awesome. So that's just a pretty basic summary of how energy or electricity is generated and transmitted here in North America. Moving to the next slide, Katelyn's going to start talking about different sources of power, and she's going to go over renewable and non-renewable sources of energy.
Great. So in the US, we have a bunch of different sources of power. The main bulk ones are going to be renewables, nuclear, natural gas, coal, and petroleum and other. So here's just a breakdown of from 1950 till now of where we get most of our energy from. So 62.7% of our energy comes from fossil fuels, and of that, natural gas is about 40%, coal is 23.5%, petroleum is 0.5%, and other gases make up 0.3%. There are a lot of different pros and cons to fossil fuels, as many of you know. Obviously, it's abundant and accessible. It provides a large amount of concentrated energy. It's a relatively low cost. It can be transported easily, and it's a pretty well-developed industry. It contributes heavily to global warming. It's non-renewable. It's unsustainable. It's heavily incentivized, which is causing a lot of issues. There's higher rate of injuries and accidents, and it's very dangerous. Natural gas is a fossil fuel energy source that forms deep beneath the Earth's surface. It is made up of many different compounds, mainly methane and other trace amounts. So petroleum and natural gas formation. So millions of years ago, it started from the decomposition of animals in the ocean, layering below sand and silt, and then us pumping down into those resources and bringing it up to the surface. Natural gas can be found in between large cracks and spaces between overlying cracks, as well as between tiny pores, depending on the type of rock, which is referred to as shale gas or tight gas. So this is just an image of gas-rich shale, sandstone, the seal, and then where we are pumping to get our gas. And then this is how natural gas is produced and delivered. So you start at a well, then you separate them, and then between oil, water, and then it's vented into a gas processing plant where different things are moved that aren't gas or oil, and then they go into a compressor station, over to an odorant, then to a natural gas company, and either into storage or to consumers. So the different sources of power are nuclear. Different sources of power. Nuclear also makes up 19.7%. Some pros and cons of nuclear power are low greenhouse gas emissions, high power output, inexpensive electricity, doesn't rely on fossil fuels, and economic impact. The cons are the back end environmental impact with the nuclear waste. Nuclear accidents obviously can create a big problem and can be very expensive. There is a high upfront end stage cost. It has been a target for terrorism, and it is technically a non-renewable source of power. So here's just a video about nuclear energy, and I'll start that.
When you think of the word nuclear, what comes to mind? It's probably some terrifying thought. I can't blame anyone for being nervous. It's a technology that we've been using for decades that can really reduce global warming. But it's not exactly something environmentalists are that excited about.
The first thing many people think of is nuclear war and mushroom clouds. You add into that major events like 3 Mile Island and Chernobyl, and now most recently Fukushima. And those have had incredibly profound consequences on people's immediate feelings and images and associations with this technology.
This isn't something where the public has the view wrong. It is a technology with a reputation that's been earned. I mean, if a nuclear power plant was being built in my town, I'd be pretty nervous about it. However, as a conservationist, that makes me feel really conflicted because these power plants don't emit CO2, and that's the main pollutant that's causing climate change.
When you look at the technology and you ask yourself, how are we going to solve this problem of climate change? To not have nuclear energy be on the table makes the job much harder.
Now, for the most part, these plants work really well. They supply about 20% of the electricity on the US power grid. But almost all of them in the US were built over 35 years ago. In fact, they look like something out of a vintage movie set. And historically, they've had 2 big problems. They produce radioactive nuclear waste, and they can be vulnerable to a disaster like a nuclear meltdown. Nuclear meltdowns happen because water that's used to cool the radioactive fuel rods can't be pumped in, usually due to something like a backup power failure. This fuel heats up rapidly, and since these reactors operate at high pressure, there can be explosions from all this excess heat. You can think of it like a balloon popping and releasing the air inside, but in this case, radioactive air. Leslie Dewan is trying to fix this. She runs a startup company called Atomic Power. They're trying to build new power plants without this problem.
Our reactors operate at atmospheric pressure, and you don't need that typical containment dome. You don't need the big stacks. You have a lot more flexibility in the architecture of the plant.
And that low pressure also means that there's no way to have a nuclear balloon pop scenario. But it isn't just about stopping disasters. Fuel itself is toxic and has to be stored underground for thousands of years. And unfortunately, we don't use it very efficiently.
The solid fuel can only stay in the reactor for a limited amount of time before it starts to break itself down and you have to physically remove it. You can only extract about 4% of the energy that you could conceivably get out of the uranium, and the rest is left behind as waste.
This is like opening up a bottle of water, taking a sip, and then tossing it out. But that's actually how older reactors use nuclear fuel. The next generation reactors are using fuel much more efficiently. Transatomic's reactor design will use fuel in a liquid form so that it can stay in the reactor for a longer period of time.
A lot of the advanced nuclear reactors can consume much more of the energy from the uranium. You can get much, much higher fuel utilization, which means that you're leaving significantly less waste behind.
And this is a trend in the field. There's a huge interest to phase out conventional fuel rods for different forms of fuel for a variety of reasons.
In the last 20 or 30 years, we've developed different types of fuel which cannot melt, and which in fact,
what do you mean by that?
Physically cannot melt.
That's Per Peterson. He's a nuclear engineer at the University of California, Berkeley, who's working on a next generation reactor design that uses an entirely different form of fuel. Many older plants still use conventional fuel rods. This new design, known as a fuel pebble, encases uranium in a golf ball-sized sphere. It's made of a very strong ceramic material that can withstand much higher temperatures, so it cannot melt and is safer to use.
Now, this one was built to demonstrate that you could fabricate it. So it does not have uranium in it, but in every other way, it is identical to the real thing.
Same weight and everything like that.
Right. And they're designed to be very safe. You can drop this thing from 10 meters onto a steel plate and it won't break. Or if I wanted to, I could drop it right now. And
so essentially, that fuel pebble is designed to be its own self-contained system. If a power failure does happen, the pebbles just empty into a holding tank where they cool down on their own. No need for backup generators or water to keep it cool to prevent a meltdown. Okay, so why hasn't this happened yet? I mean, we have better materials. We have reactors with new designs and fuels that make less waste. It actually sounds like we have the answers to our problems. So what's the catch?
You know the old phrase, you never get a second chance to make a first impression. People's first impression of nuclear energy and nuclear power was mushroom clouds. And if it's got the word nuclear associated with it, it's just going to be very difficult to convince people, no, we mean it this time. This one's safe.
It puts nuclear energy in a very challenging place. Right now, even solar and wind are cheaper than nuclear power. So there isn't a lot of economic incentive to build these power plants. And if no one wants to build them, then companies that make the parts go out of business or go somewhere else where new plants are being built, like China.
Those that are under construction now, the economics have been really grim. The number of plants that have been started and the price overruns have been massive.
One of the problems is just simply transporting the components. Instead of getting the parts locally like we did in the 1960s and 70s, the parts today are shipped from overseas. And these aren't just basic nuts and bolts. These are huge, complicated components. If a section of a reactor vessel breaks during transport, it needs to be fixed, or a new one needs to be built and reshipped, taking more time and money to complete.
I think that it's going to be very interesting to see how startup companies tackle those problems. And this is a very different space from where the traditional technology evolved.
Now, rapid innovation has happened in other industries. Look at SpaceX, for example. They went from a concept rocket to delivering supplies to the International Space Station in a matter of years.
The technologies that are being researched now that look very promising range from small modular reactors, where the whole nuclear power plant comes in the back of a flatbed truck, gets parked, plugged in, and when the fuel is used up, simply gets taken away as a unit to be reprocessed.
These small modular reactors could have specific uses, like powering a data center that's using electricity around the clock. We have startups building cheaper, smaller reactors that don't melt down. We have engineers making fuel that doesn't produce much waste. While the public image of nuclear energy is rooted in the past, the nuclear energy of today is a whole different ballgame.
People like me view nuclear as being a necessary piece of carbon-free energy production. There's less of that fear of nuclear and more of sort of a need to use everything in our toolbox to combat climate change.
There are other energy sources that we may be overlooking. For example, scientists are actually turning to poop to power cars. Head over to climate.universityofcalifornia.edu for more.
Yeah, so I just thought it was an interesting video to kind of go over nuclear energy and, you know, its past and its future and some new ideas that are coming out. Sorry for the background noise. That's my roommate's dog. So nuclear energy specifically comes from splitting atoms in a reactor to heat into steam to turn a turbine and generate electricity. And the fuel for nuclear energy is uranium, like that golf ball sized ball that he was holding. So this is just kind of the process of how fission splits the uranium atom. And I won't try to describe it because I have very little knowledge about it. So some other different sources of power are renewables, which are hydropower, which is 6.6%, wind, which is 7.3%, biomass, which is 1.4%, which includes wood, landfill gas, municipal solid waste, other, and solar, which is 1.8%, which is PV and solar thermal, and geothermal, which is 0.4%. And now I'll go into each of these. So hydropower relies on the water cycle, and that determines the power that is produced. The volume of water flow and the change in elevation or fall from one point to another determines the amount of water or the amount of available energy in moving water. So as you can see from this diagram, you start with a reservoir, the water goes through the intake into a penstock, which turns a turbine, and then that water continues into the river. And as the turbine turns, it provides energy into the generator and the powerhouse, and that is then distributed into long distance power lines. Pros and cons of hydropower: it's renewable, it's green, it's reliable, it's flexible and safe. There's some risky environmental consequences. including, just to name one, our fisheries. It's very expensive. In droughts, it can't produce as much, and it holds a lot of water back from other resources, and there's a limited amount of reservoirs. Wind. So the wind turns the blades, which turns a shaft connected to a generator that produces electricity, which you can see in that top photo. Over the course of a year, turbines can generate energy at about 90% of the time, and typically they are about 262 feet tall, made of tubular steel hubs, support a hub with 3 blades and a nacelle, which houses the shaft, gearbox, generator, and controls. So if you're looking at that bottom photo, the wind is turning the wind turbine, which is turning that gearbox and generator in the middle, which that energy then goes down into some buried cables, goes to a remote computer monitoring and control, and then goes back into the buried cables, goes into a high voltage transmission transformer, and then is spreads to the transmission lines to consumers. So the pros and cons of wind energy are it is cost-effective, renewable, sustainable, savings for landowners, rapid growth. There's rapid growth and huge potential, and can be built on existing farms and developed land. Cons would be its reliability on wind and the weather, the threat to wildlife, noise and visual pollution, high upfront costs, and its effect on the environment. Biomass energy is the energy that is derived from the organic matter of plants and animals, such as dead plants, trees, grass, manure, garbage. In the top photo, that's pellets. Biomass contains energy first derived from the sun that is then transferred through direct electricity and heat and indirect biofuel means. So some other types of biomass in that other image you can see: garbage, crops, alcohol fuels, landfill gas, and wood. It can be burned through thermal conversion, turned into biofuel, biochar, black liquor, and used for hydrogen fuel cells. So here's just another diagram. So you start with a forest. The trees take up CO2 and release oxygen. The trees are cut down. There's wood residue. Then they're taken to a pellet factory, shipped, and then taken to a biomass power plant, and then they let out CO2, and then once again the trees take it up, and so it's just a kind of a cycle. Some pros and cons of biomass energy are it's renewable, reduced fossil fuel use, carbon neutral, widely available, reduces waste, and can be used in many forms. Some cons are it's not entirely clean burning because it still releases CO2. It can lead to deforestation. It can be inefficient, and it requires large amounts of space, and it can be very expensive. Solar energy is energy that is converted from the sun into electrical or thermal energy. 3 ways to harness solar energy are photovoltaics, solar heating and cooling, and concentrating solar power. And they work when photons hit a solar cell, they knock electrons loose from their atoms. And if conductors are attached to the positive and negative sides of a cell, it forms an electrical circuit. So if you look at that top photo, you can see the sun is hitting the panels, which is then going into a converter, then into a battery, and then you can see what your energy input is. And then if you look in the bottom one, solar panels convert sunlight into a DC current. An inverter converts that electricity from DC to alternating current. The AC powers your home, and then extra electricity is then sent to the grid. Pros and cons of solar include that it is renewable, reduces electricity bills. There are a lot of different applications you can use it for. It's relatively cheap, and there's a lot more technology development that can be used to increase it. Some cons would be the cost. Weather dependent, energy storage is expensive, and it uses a lot of land. Geothermal energy is heat derived within the subsurface of the earth. It can be used for heating or cooling purposes or harnessed to generate electricity depending on its characteristics. The main countries that use it are New Zealand, Iceland, El Salvador, Kenya, and the Philippines. So if you look in that top photo, you can see that there's magma beneath the surface, which is then heating a reservoir. From there, it goes, the heat from that goes into a turbine, which it spins, and then goes into a generator, then to a transformer. It is then condensed, sent to a cooling tower, or the extra is sent to a cooling tower, which is then pumped back down. Cooling water is pumped into heated rocks where it is converted to steam, which then rises to power the turbines and generate electricity. Excess water is cooled and the process starts again. And then you can kind of see the same thing in the image below, where it starts with hot water, turning to steam, turning the turbine into a generator, sent to a cooling tower, and then the water's then injected back down. Pros and cons of geothermal. Some pros are it's renewable, it's environmentally friendly, no fuel is needed, there's an abundant supply, smallest land footprint, and again, innovation for technology. Some cons are it's not suitable to every region, very expensive, surface instability, environmental concerns, and high temperatures are needed. And then we'll go into end user electricity usage.
Awesome. Thanks, Caitlin. That was a lot of information about renewable and non-renewable energy. No, I love it. So obviously a lot of different ways that energy can be used and produced and transmitted. As consumers, we have a huge responsibility of the way that we consume this energy. And as you learned in the brief video at the beginning of the presentation, we have a really intricate and complicated energy production system and transmission system, and any energy that is produced and put into this grid has to exactly meet the demand that end users are pulling from the grid. And that's like, so if you have too much energy that's being demanded or too much that's being put in, that's how you get blackouts. So I have a chart on the next page that breaks down the US residential electricity consumption for 2019. So as you can see, the top two consumer uses of electricity in the United States are cooling and heating, 16 and 15%. So this equals, with water heating, almost half of our energy usage in our homes in the United States, which is just insane because that's not even considering all of your appliances and everything. If you take note at the bottom, there's an other uses, 31%, which includes just very small, minor electric, sorry, it's really hard, small on the screen, small electric devices. So just like basically all of the really small appliances in your house that add up to a pretty large percentage of the energy usage in our homes in this country. So if we go to the next screen, I want to talk really quickly about phantom loads, because that 31% is a huge usage of phantom loads. Phantom loads are essentially the electricity that any appliance or device consumes when it's turned off. Some examples of these devices are like your voice activated devices, like your Amazon Echo, your Google Home, anything with a standby mode, like your monitors, your printers, TVs, anything that basically goes into a sleep mode. And there are a lot of appliances in our homes currently, like microwaves, coffee makers, and ovens. If you think about it, even when you're not using that, it's still plugged in and it's still using a small amount of electricity. And a really easy way to tell that is if it's something that has a light that is always on. So some chargers have an indicator light that indicate it's still drawing some sort of power, or anything with like a clock or something like that that is always like drawing minor amounts of electricity from the grid. So it may not seem like that much, and if you were to use a kilowatt meter, it really is pretty minimal. But if you think about all of the different devices in everybody's home that are on 24 hours a day, this represents about 23% of Northern California household electricity consumption. So basically a quarter of our electricity consumption in Northern California is electricity used from inactive devices, so those phantom loads. It's just an insane amount and a ton of money that we could be saving. Phantom loads in the US, let's see, I forget what year this was from, but the total cost for the whole US, when you average it out, it equals about $165 per US household each year. And if you live in a higher tier area, it's even more. So that's a pretty decent amount of money that you could be saving every year just by going around and unplugging these devices. So really quick, Caitlin's going to go over some tips for conserving energy.
Yeah, so some just different obvious and not so obvious ways are, changing your day-to-day habits, which can include, replacing your light bulbs with LED, unplugging devices from outlets when not in use, using or purchasing smart power strips, turning off the lights when you leave a room, changing your energy provider to renewable sources. I know that in Sacramento, I was able to change it. So 100% of our energy comes from renewable sources. And I think it was like an extra $5 a month. Making sure to cover your pots and pans when cooking just helps conserve energy, as well as, heats things up faster or keeps them at a better temperature. And maximizing daylighting to reduce heat and electricity use. And I mean, there's a lot more. I have some resources at the end that you guys can flip through if you want to. And yeah.
I was still on mute. So one way that I was able to go through and in my own home here in Northern California and find some ways to start saving energy at home was through the use of this DIY home energy saving toolkit. They're created by North Valley Energy Watch. You can find them in the local libraries. Butte Environmental Council, which is a local nonprofit in Chico, has them for free. And I believe the planning department at City Hall has them as well. So you can check these out for free. And it has a bunch of tools and different things that you get to keep in order to start making your home more energy efficient in a lot of different ways. So on the next screen, I have a breakdown of what all is included. So the items you get to keep include LED light bulbs, which are definitely more expensive than fluorescents. So 4 LEDs is not enough for your home, obviously, but it's a really good start if you take them and go through like the lights that you're using the most often. So if you have like a lamp in your bedroom and you're spending the majority of your time in there, is what I went ahead and did. And it kind of you get to like start getting used to using these and looking for them in stores. You get a couple low flow faucet aerators, which are just these little things that you screw onto your faucets, and it essentially aerates the water so that you're using less water. There's a shower timer. I forget how much time it is exactly, but it essentially just helps remind you to start taking shorter showers. Outlet gaskets are these little, like almost sticker-like things. They're insulators for your outlets. So you unscrew the little outlet plate and you stick these things underneath it, and it just helps insulate, because if you think about it, like that's a section in your wall, multiple sections in your wall where there is no insulation, and warm air or cool air is going through there and you're losing energy energy that way. Weather stripping is another sticker type appliance that it comes in different thicknesses, and you essentially stick it around the perimeter of your windows and your doors, and it just helps keep that air in or out so that you're saving energy there. Some water leak detection dye tablets. You can see if like your toilet is leaking. A really awesome hose nozzle. So it's just one of those little sprayer heads that you attach to your hose, and I use it in my garden all the time. And then a low flow shower head. So all these items are free that you get to keep, and then you also get all of these tools to help sort of assess where you might be wasting energy in your home. So a kilowatt meter, like I mentioned before, is a device used to measure the energy usage of an appliance. So you plug it into the outlet and then you plug your device into it, and you can either see the instantaneous reading of what the wattage is that device is drawing, or you can plug it in over a certain amount of time and it'll tell you like the life cycle or how many kilowatt hours that device is using. So the average number of watts per hour that your device is pulling. Let's see, what other items are of interest on here? The infrared laser thermometer. So it's a little thermometer that you point and it'll give you the reading, and it's really useful looking at like your doors and windows to see where you might be losing either heated or cooled air. A water flow rate bag to see how much water like your shower or your sinks are using per minute. A thermometer for your refrigerator to see how efficiently your refrigerator is heating is cooling. And then an awesome instruction booklet that shows you how to use all these things and other ways that you can make your home more energy efficient. So it's just an awesome toolkit. I used it when I was in college at Chico State. It was a huge lifesaver. I still use a ton of these items that I got to keep every day. And there's all kinds of resources out there like this that you can use in your homes. Let's see. So that pretty much wraps up what we had for information for you today. Caitlin mentioned this is our list of either sources or other resources. So I don't know if there's anything you wanted to point out there.
No, I think I'm good. I think when we send this out, I'll send out just maybe a couple other sources for how to conserve energy. I know being in school and renting, it's hard to know what you can and can't do, and especially if funds are low, but and especially in the times that we are in currently. But you can maybe always reach out to your landlord and see if they would have any interest in putting in these, energy conserving products, because I think it's a pro for the people who come in after them, or if you want to purchase them and then take them with you, that's great also. Yeah, so that's just kind of how our different sources of energy, and how we each get them to our house. So yeah, Ashley, you have anything else you want to say?
No, just that we're going to be sharing this. I believe Dr. Mark will be sharing this video for your lectures in a couple weeks for his sustainability issues class. We will also be including these slides, so if you want to follow any of the links or save the videos, or kind of check any of our research that we put into this, you're more than welcome to. And if any of you have any questions about Climate Corps or what we do, or want to talk more about any of this, feel free to reach out through Dr. Mark, and at least I'm more than happy to have him give out my contact information, and I'm assuming same for Katelyn.
Yeah, me too. Yeah, feel free to reach out to ask about Climate Corps, or I guess anything about this presentation, or if you have any questions about post-college life.
Yes, we both survived it, at least the first few years. And we are definitely an open book on any resources or help you might need if you want to go into sustainability. Awesome. Well, thanks for helping me out with this, Katelyn. And if anybody has any questions, reach out, and have a great day.
Thank you, Ashley. Have a good day.
You too. Bye.